Here we go, chemistry students. Quantum numbers, electron configurations, and orbital notations for Chapter 4. Dive right in talking about the quantum mechanical model of the atom. Basically, it's the most current understanding that we have of what the atom looks like and how it behaves. It's based off of the Heisenberg uncertainty principle, which states we do not know exactly where an electron is around the nucleus of the atom, but we can make our best guess at denoting where it is. These electrons are found in orbitals, or electron clouds, which represent a three-dimensional shape around the nucleus of an atom, again where we're most likely going to find an electron. I'd like to take a brief moment and compare these orbitals of the quantum mechanical model to the Bohr model that we are a little familiar with. This is the Bohr model of the atom, where electrons are on set paths around the nucleus, and they cannot vary from those paths. So, as an example, in each orbit, just like planets orbit the sun, we have electrons. The Bohr model said if an electron was right here, that could not exist. We cannot have an electron at that spot. It would not work, it would not exist there. It has to be on a set energy level. Now, this is different than the quantum model of the atom, which has these orbitals represented as electron clouds. These clouds are different shapes of where an electron may be found. And there is a chance of finding an electron here, just as there is a chance of finding an electron here, or even out here in our 3s orbital. You have the probability of finding electrons at different areas based on their energy levels. Let's talk about these quantum numbers that attempt to denote where these electrons are at. Basically, quantum numbers are, again, trying to tell us a little bit about the electrons and how they behave in an atom. These electrons are again found in orbitals, which you need to get the definition down if you do not have it and know that definition. Each electron is assigned 4 quantum numbers. Here's a brief look at what these 4 quantum numbers look like. Each electron is going to represent its area in space around the nucleus. And we can basically think of this as a street address, where our 4 quantum numbers, N is going to represent the energy level. Think of it as the street number to your house. L is the shape, S, P, D, or F, and we're going to look at the shapes next. Those are the street names where the electrons live. M is its orientation or its zip code. Its zip code as far as its region of space that it occupies. And you have to think three-dimensionally here. There's vertical, there's horizontal, and there's in and out. And then the spin, which we represent with these little arrows here. This is an up and down arrow. Now, I make my arrows as a typical arrow would be like that. I end up making my arrows and just erasing that part of it, so you end up with just that half an arrow. It's a little quicker, and we will talk about this a little later, but it's good to know now what this represents. So I'd like to pause and look at a video that talks about these shapes of the electrons. Let's look at an s orbital. This is an s orbital. It is a sphere. It is going to be able to hold 2 electrons, and it's one of the smaller orbitals that exist for our quantum mechanical model of the atom. Our next orbital shape is a dumbbell, which is similar to 2 balloons put together. A dumbbell, or a p orbital, is going to be able to hold 6 electrons. And there are three p orbitals that exist at each energy level. And the reason is because in orbital diagrams, you're going to have 3 horizontal lines above the p. And you can turn each p orbital 3 directions. So right now it's horizontal. So the electrons that would be in this orbital, there can be 2 of them that are going around the nucleus, which is right here, around the nucleus side to side. I can turn the orbital up and down. The electrons are going to be in an orbital up and down or in and out, and they are moving in and out. So there's 3 different directions. Our last orbital that we talk about in general chemistry here is the d orbital. This one's the big one. It really looks like this, like a 4-leaf clover, and the d orbital can hold 10 electrons. It's the largest orbital that we will deal with. And in 10 electrons, that means that each d orbital can hold, again, 2 electrons. So in the d orbital, there are 5 different orbitals. This orbital, you have to imagine 5 of these stacked together. You have one that goes up and down, one that is going to exist in the flat or horizontal plane, one that is going to exist in and out, one that's angled to the left, and another one that's angled to the right. And that will hold 10 electrons, our largest orbital.